So this idea can be illustrated quite nicely through a simple picture. Suppose we've got just 2 movies and 2 users. So we can easily compare 2 points on 2D grid. The 2 points are the movies A and B, and we've got 2 users, 1 and 2. The points are the movies, and the axes are the users. So movie A is getting a rating of 5 from user 1 and 1 from user 2. So movie A is getting a 5-star and then a 1-star from these 2 users, whereas movie B is getting a 2-star and a 5-star from these 2 users respectively. As you can tell, that these 2 movies are kind of very different. Okay, they are basically liked or disliked in an opposite polarity by these 2 users. And indeed, this means that this angle theta is kind of big. What is this angle? This is the angle between 2 straight lines. One is the line from the origin to this movie's coordinate, and the other is from the origin to this movie's coordinate. And if these 2 coordinates are far apart, one quantification of that is the angle theta here. If we measure the cosine of that angle, that is a particular number, and we use that number to describe how similar or dissimilar A-B movies are. This is called cosine coefficient. It is a particular instance of similarity metric that we'll be using here. So how do we write down the cosine coefficient here? I'm going to say the cosine coefficient between 2 movies ij is called dij, and if you remember from basic geometry, analytic geometry, it's really this point viewed as a vector from origin to that point. Okay, call that a vector Ri. It's a vector transpose Rj, that is this point viewed as a vector from the origin to that point, divided by the normalizations, that is the size of I, L2 norm, and the size of J, also L2 norm. So we can view these 2 ratings for 2 different movies as 2 vectors, Ri and Rj, and the cosine of the angle is the standard formula, which is just their inner product normalized by the sizes. And this in the longer form just means RUI and RUJ summing over all the U's who have rated both movies I and J, that is. That is the inner product of these 2 vectors, divided by the square root of, just by the definition of L2 norm of the 2 vectors, RUI squared, summing over all the U's. It's the same set of U as here in the numerator, and summing over the same set of U, RUJ squared. That's just the L2 norm of these 2 vectors. So this dij is the cosine coefficient, defined as such geometrically as the cosine of the angle theta, and algebraically defined as such. Now, because we have already shifted the R data from R to R minus the baseline predictor R for each UI pair, we call this R2D UI at the end of the last segment of the video. So strictly speaking, we should put 2D here. So all looking at the R2D value that has already subtracted the influence of the baseline predictor. So now what we need to do is to look at all the pairs of movies ij except movie II back to itself, and then compute this relationship.